This video will give you the practical way of solution to find the shortest path using Floyd's algorithm. The graph is provided. This is a directed graph, directed weighted graph. You can see the weights here and it is directed. The first step is to make a initial algorithm, initial matrix, which will be having a 4 by 4 because we have 4 nodes here. We will be having the matrix as 4 by 4. So now you will write the weights of each path. From 1 to 1 there is no loop, so just make it as 0. 2 to 2 also you don't have loop. 3 to 3, 4 to 4. The remaining 1 to 2. 1 to 2 you have the weight to be 5. Sorry, this is 5. 1 to 3 you don't have any path from 1 to 3. You have a inverse path, so just make it alpha. 1 to 4 you don't have any path, make it alpha. 2 to 1 you have a path with weight to be 50. This is 50, this is 30. 50, and here again it is 15, here it is 5. 2 to 4 it is 5, then 3 to 1 it is 30. 3 to 2 we don't have any path, so make it alpha. 3 to 4 we'll be having a 15 here. 4 to 1 we'll be having a 15. 4 to 1 is 15. 4 to 2 there is no path, so make it alpha. 4 to 3 we have a path with weight 5. So this is your initial matrix. So after this what we will do is, hereafter we don't consider this graph, we will consider only the initial matrix. So the next steps what we are going to follow is, we have 4 nodes. We will be considering 4 different matrices: A1, A2, A3 and A4. Finally, a path matrix will be constructed. So in A1 what we are going to do is, just we are going to construct the same pattern of 4 by 4 matrices, but the values will be changing here. How we will change the values is, you can see here, we will now construct an intermediate matrix A1. What we are going to do here is, when we want to construct a path from 1 to 1 it is 0, so just make this diagonal to be 0. This value will never change because we don't have any loops there. From 1 to 2 it will be, for constructing a value 1 to 2 you will be constructing an intermediate value like 1 1 1 2. 1 is your intermediate value, and path from 1 to 1 is 0 plus path from 1 to 2 is 5. This is already 5 here, so this both values are same, so you can have the same value here. If you go with 1 3, it is 1 1 plus 1 3. This is your intermediate value. 1 1 is 0, 1 3 is alpha, and already 1 3 is also alpha, so this also remains unchanged. Then 1 4 will become as 1 1 plus 1 4. This is your intermediate matrix value. 1 1 will be 0. 1 4 will be again alpha, which is already alpha, so there is no change. Make it alpha itself. When you come to 2 1, you will be having it as 2 1 is equal to, yours is your intermediate matrix 21 plus 1 2 1 1. This is your intermediate value. 2 1 already is 50. This is also 50, plus 1 1 is 0, which never changes. This is 5. Again 2 3, which is going to be 2 1 plus 1 3. This is your intermediate value. 2 1 is 50 plus 1 3 is alpha. For 2 3 it is 15. When it adds with alpha infinity, you can see that this will be your minimal value. So 15 will be less than 50 plus alpha. So you can have this value as 15. You have to write here the minimum value only. If you don't find minimum value, write the same value as such. Then you will go with 2, 4, which is 2, 1 plus 1, 4. Value of 2, 1 is 50. Value of 1, 4 is alpha. Value of 2, 4 is 5. Since we have an infinity here, we will just have this as the minimal value and take 5 as such. Then for 3, 1, when you consider 3, 1, it will be 3, 1 will be 3, 1 plus 1, 1. 3, 1 is 30. 3, 1 is again 30 plus 1, 1 is 0. These both are same, so you will have 30 as such. When you come to the next, 3, 2, you will be having 3, 1 and 1, 2. So we are going to compare this and this. 3, 2. What is the value of 3, 2 here? It is infinity. What is the value of 3, 1? It is 30. What is the value of 1, 2? It is 5. 35. Obviously, you know that infinity is higher value and 35 is minimum value. So you take this 35 here. Again, when you come for 3, 4, it is 3, 1 and 1, 4. Value of 3, 1 is 30. Value of 1, 4 is alpha. Value of 3, 4 is 15. Obviously, this will be your minimum value. Take this as 15. And again, when you go for 4, 1, when you go for 4, 1, it is 4, 1 plus 1, 1. Value of 4, 1 is 15. Again 15 plus 0. This is same, so have it as 15. You can see here this value is changed here. This is alpha, infinity, and this is 35. So just square it out. Then 4, 2 will be 4, 1 plus 1, 2. What is the value of 4, 2 here? Infinity. 4, 1 is 15 plus 1, 2 is 5, which is nothing but 20. So this is your minimal value. You can take 20 here. Here you have an alpha. Here you have a 20. So square this. Then coming to this, 4, 3 is equal to 4, 1 plus 1, 3. What is the value of 4, 3? It is 5. What is the value of 4, 1? It is 15 plus value of 1, 3 is alpha. So this will be your minimal value. So have it as 5. So this is your first constructor matrix. With again this diagonal will be 0. Now you can see 1, 2. I want to find the value for 1, 2. So 1, 2, value of 1, 2 with intermediate value as 2. You have to take the intermediate root 2. 1, 2 plus 2, 2. What is the value of 1, 2 here? It is 5. Value of 1, 2 is 5 plus value of 2, 2 is 0. This is almost the same. So we take 5 here. Again 1, 3 is equal to 1, 2 plus 2, 3. 2 is your intermediate node. So 1, 3 will be value of 1, 3 is alpha. Value of 1, 2 is 5 plus value of 2, 3 is 15, which is 20. This is your minimum. So you will have 20 here. You can see the change in alpha here, infinity here. So mark this as the change. Again, when you go with 1, 4, it is 1, 2 plus 2, 4. This is your intermediate node. Value of 1, 4 is infinity. Value of 1, 2 is 5 plus value of 2, 4 is 5. So you will have a 10 here. This is infinity. This is your minimal value. So this value also has changed from the previous matrix. And when you go with 4, 1, it is 4, 2 plus 2, 1. 4, 1 is 15. 4, 2 is 20. plus 2 1 is 50. This is your minimum, so you will have 15 as such. Similarly, for the remaining, when you calculate, you will have 20 as such and 5 as such. There is no change. What is the next change is 1 2. If you are going to take 1 2, your intermediate value will be 1 3 plus 3 2. This is your intermediate value. So 1 2 is 5 here, 1 3 is 20 plus 3 2 is 35. This is 55, this is 5, this is your minimum, so have 5 as such. Then when you go for 2 1, it is 2 3 plus 3 1, 2 1 is 50, 2 3 is 15, 3 1 is 30. So here you will get 45 and here you will get 50. This is your minimum, so take 45. There is a change in this 50 and 45 square, so just have it as such. When you calculate, you can find it. Okay, now when you go for A4, it is 1 2 3 4, 1 2 3 4. As I told you before, you have to consider only this matrix, not the previous matrices. Now we can calculate for 4 intermediate. So this is your 0, fill it up with 0. This is your minimum value. Again 1 3. When you take 1 3, it is 1 4 plus 4 3. 1 4 is 10. 4 3 is 5. 1 3 is 20. So 15, 20. This will be your minimum value, and so you take 15 here. You can see the change here. This is 20 and this is 15, so mark it out. Then again you have to complete now 2 3. 2 3 you can do it as 3 4 2 4 plus 4 3. 2 3 is 15, 2 4 is 5, 4 3 is 5. So this is 10 and this is 15. So there is a change here and here. So after constructing all the 4 matrices, this is for intermediate 1, 2, 3 and 4. We will construct the path matrix. In path matrix, again the same 1, 2, 3, 4. This is a 4 by 4 matrix, so make it as 1, 2, 3, 4. So in this, out of this 4 by 4 matrix, what we are going to do is just check whichever is changed. In A1 this and this is 3 2 and 4 2 is changed. So 3 2 and 4 2 is changed in A1. In A2, 1 3 and 1 4 are changed. This is in A2. And in A3, 2 1 is changed. This is in 3. And in 4, 1 3 is changed. Again 2 1 is changed. Again 2 3 is changed. So the remaining, there are no changes. You can just make it as 0. And now you can see, out of these, this is the highest. Just mark with the highest value. Now you can see that from 1, I can travel through the highest path, which is 3. So this is 3, 2. From 3 it will go to 2. Again from 2 it will go to 3, which is a cycle, or I can go to 1, which is again a cycle. So this path cannot be established. So I can start from 1, then with 4, then from 4 to 2, then from 2 to 3, which doesn't form a cycle, and this is your all pair shortest path.